origins of the internet dates back to the 1960s with the initial experiment about computer communication systems. At the initial stage, it was conceived as a global network to exchange information and digital contents without any restriction of time and thus breaking the distances. About 2 billion people connected to the internet with the advent and proliferation of mobile devices. Today, the vision of Internet of Things has expanded to connect everything from industrial equipment to everyday objects. The way how we access the internet has also changed drastically. The number of electronic devices that can be connected to the network services has increased manifold. But internet connectivity is also possible beyond these devices. Every object around us may be connected, thereby collecting, processing, and sharing information. The Internet of Things opens up a new world of infinite possibilities.
My name is Mombasawala Mohmedsaeed. I am called Bomba. I am the General Manager for Application Engineering Group in Keysight, and I am responsible to provide the pre-sale support and the trainings for all the customers that we deal with in India for our instruments. By definition, IoT is the Internet of Things, which says that anything which is natural or man-made, if it has an ability to communicate over network, is the thing which can be actually a part of an internet. So we call IoT as any object which is ready to communicate to the network. For the fundamental fact that we want the decisions to be taken fast, for the fundamental fact that we want the uniformity in the decisions, we want to have the commonality, we want to have the consistency in the decisions, and we want to apply the policies across whatever things we operate in. Now for that purpose, if we have a central agency in which we can have all the data from any of the object or any human or any medical system, whatever, education system, then we can have a better visibility both for financials, economics, health, or any of these things, and that would make life much more simpler. So it's basically ending up for human to make their life simple. When you look at different segments, there are different interesting examples, and we can have examples which actually can be touched by many people. For example, connected cars, because we know automobiles which are more or less isolated object as of now, where we are not able to communicate from the object to elsewhere except as human talking on mobile. What if I have the vitals of the car being sent to the central location? What if I have the details of my car or the communication within the car or the humans within the car sent to the central location? I can actually take a lot of decisions on traffic, on flow of traffic, on the health of different equipment that are moving on the road, on the speed governance, on compliances, etc. I can also understand a lot of infotainment, what can be restrictive, what cannot be restrictive, what is impacting human behavior within the car, etc. With the help of this. So this is one such iota of example. I would say there are a lot of other examples which will be enabled through IoT. IoT is not something that is a revolutionary thing. It has evolved right from the existing available technologies. Like we have the technologies called Bluetooth, LoRa, Sigfox, Zigbee, LTE. These kind of technologies are enabling Internet of Things. So when you say this 5G or data cloud, they are actually somehow connected to Internet of Things. The only difference that one has to visualize is Internet of Things are related to anything which is human or non-human. So there are so many objects which can send the data. So you have maybe 50 billion devices, that's what people say by 2020 that will be communicating. What changes in the environment for testing is are few things. One is Internet of Things is not manned or not attended to. For example, you have a smartphone, you attend it every day, you can recharge your battery. In Internet of Things, you mount the device to communicate and the battery is not going to be recharged. So you have 10 years of battery life. The testing paradigm is changing towards these areas which we were taking for granted kind of thing. For example, we have to test the battery for the life of 10 years. Can you wait for 10 years for the battery to bleed? You can't wait time wise 10 years. So you have to test it out to bleed the battery and determine how much it is going to last. Second thing is IoT is not a very wide band kind of an area. It is a very narrow band area. So it sends some data, it receives some data. There are a lot of decisions that are happening at the central locations on combinations of data. So the bandwidth requirement is less. Such kind of tests are little different because when you have less bandwidth requirement but so many devices which are actually hooking up onto the network and sending the data, the spectrum requirement, the testing requirements are different, the noise requirements are different, battery drain requirement are different. So while the technology is not something that is allowing us to evolve a new methodology of measurement, we are just fine-tuning the current available methodology to fit into the IoT requirement. So from the test and measurement perspective, our own knowledge of measurement science is carried forward in a refined manner to accommodate lot many devices, provide the consistency of use of these devices. People are mindful of the fact that you cannot test in R&D each and every device. You cannot test probably all the device to the same degree in manufacturing also. Probably some pass fail kind of a test, initial go no go kind of test, that should be enabling this device. So we have different categories of test. One is R&D and another is manufacturing, and that is giving us some kind of change. If you look into the traditional methodology of test, all test and measurement instruments are very expensive from any company. So you have something to test, but the measurement gear is always very expensive. Now look into IoT. If you have a device, the device are very cheap device. You cannot have a $1 device and $100,000 of a test instrument to test it. So one of the challenges that we face is to make the economics work for this industry in the test bed itself. While the methodology of test is, I would say, similar or little scaled down or little advanced, but we have to evolve a method in which we can test lot many devices in a very short time. We call it as a yield, or support these kind of testing of millions of devices on a very economical manner. So we have to evolve a methodology of implementation, we call it as MOI, in our test gears, which allows lot of testing of this type. Another thing that I want to touch base is the enabling of test and measurement instrument with the software methodology. The measurement science is shifting from hardware to software, and a lot of applications are enabling it. We have to evolve new applications that reduce the dependency on hardware and have the applications which can be applied across lot of small hardware and makes it economical. So lot of things are evolving like that. This is in parallel to the way IoT is also evolving. IoT has a hardware platform, then it has the data cloud, and then it has a software platform. Software platform is much bigger than the hardware platform because that's where you have all the decisions. Our T&M industry is also moving in the similar area. We are going towards extremely large amount of software in the test gears to make it economical. So one challenge that I would say for us is to make it extremely economical for people to use it. When we talk about IoT, people are just worried about, you have something to send as data and then it reaches. But if you look into joining all the dots of this data, for example, I am treated as one of the object of IoT. I start from home, come to the office, and I am being tracked. Then I go to the evening for dinner party and then go somewhere else and go back home. Somebody has the entire mechanism of finding out, what do I do? My personal life, my private details may be exposed. That is one part. Second can be on the financial. What is important element of IoT besides the networking and application is a security, and this is going to open up a new area. Now when we talk about 50 billion devices, as soon as you put the security measures, it starts slowing up the thing, it start needing a lot of hardware gears and the data cloud to do decision making, because you have to decrypt the data, make decisions and put the right perspective. Privacy and security are going to be two important areas that industry has to address in due course of time. Current focus is more to enable things. I'm sure in a year's time people will be talking a lot on securities and the privacy. For example, I have all my credit card details, I have my family details, I have my personal details. When you talk about IoT in the medical care also, if I have a wearable which transmit all my vitals, I may not want to get things about my medical status exposed. Those privacy and the details has to be protected. So this is going to open up a new avenue for sure. From the test and measurement side, while Keysight has a limited role to play, it is going to put a new impetus in software industry, wherein they will have to find the software packages with a robust encryption mechanism and test out different algorithms with which they can provide privacy and security. So it's going to give a new dimension to the software industry testing also. There is a serious potential threat if the security and the privacy is not taken care of. So I would say if government or the governing institute has to do something, they have to ensure that this is in compliance to the citizenship right. While IoT will have a lot of details about individuals, about companies, about objects, about segments, about systems which can be related to national security also, government has to ensure that there is a limited exposure to people en masse about this security. That is one part. As far as availability of resources, like many of the communicator of IoT are on radio interfaces. Availability of spectrum and the security at the air interface remains another concern. The third important thing that I have to tell is the amount of data that we will have. You will need huge clouds, and enabling these clouds and providing mechanism to enable this as a policy from the government. Some government has to look through the policy that enable huge data centers and cloud. So that is another area that I would see as a catalyst that government can play. Is not by itself a technology. It actually takes input from different technologies, combine it, and you can see it from the slide. It finally collapses everything into one location, allows you to have decisions, etc. So nanotechnologies, biotechnology can be one of the data points within the technology. As of now, the concentration is in terms of what we can provide as an immediate benefit to human, in terms of healthcare, in terms of traffic conditions, in terms of communication, in terms of ease of doing business, etc. I'm sure in due course of time people will move towards nano options and other options. This is not much talked about thing in IoT as of now, not from Keysight point of view that I know of, as a nanotechnology, as a component of an IoT, not so much that I know of. Now we have spoken a lot of things as considering India, right, as a market, government, availability, what we can solve as a problem for the country, etc. Now take a global perspective. One of the things that can accelerate this is standardization. Like people are coming out with standardized method. For example, there are different technologies like Bluetooth, Zigbee, LoRa, etc. Okay, we have also LTE. quite a considerable efforts are being put to standardize the spectrum usage and the methodology of communication. If that gets more streamlined, if we have better standardization, people would start complying, interoperability will improve, and that would catalyze the IoT. I'm not touching here the encryption and the security part. That eventually might also have to be standardized, at least policy wise, if not the algorithm wise. I would say be fair to people. What does it mean? I mean, you have a lot of things, a lot of data of people, right? So be ethical, be fair, okay, don't expose anybody, don't misuse it. IoT is going to go in its own way, and people will reap the benefit of it. From industry point of view, from those who enable IoT, they have to be more ethical, I would say, and truly abide by the policies of the government to ensure that the leadership is seen irrespective of the availability of the information. Okay, so that's something that I would say. I would also say one more thing. IoT is about the things, right? And when the industry leaders start attempting making devices, we want to make sure that these devices have a very high degree of resiliency and reliability. So they are fail-proof kind of thing. You can recharge your phone, you can reboot your phone. What if you have the Internet of Things of the street light? Right, you cannot keep on changing it. What if it is related to the monitoring of number of tigers, right? You mount some internet IoT device and then you are monitoring the tiger and their population, their health, etc. You cannot keep on changing it. So we need a very reliable device. Make sure that you use reliable electronics, even if it is very economical, and stay ethical. That's what I would say to the industry leaders.
Day after day, there are more objects and devices that use the internet, which in turn has contributed to the creation of a smarter planet. It is estimated by the year 2020, there will be more than 50 billion objects connected to the internet, that is an average of 6 devices per human on the earth.